in geometry, we say that two shapes are congruent when they are same size and same shape. Okay? We say that two figures are similar if they are the same shape, different size. And that's what we're going to focus on for today. They're going to be the same shape, but a different size. And they're going to have to be the same shape in a perfect kind of way. And I'll explain that to you in a minute here. What's going to be different about these figures? You're going to take a look at a couple of, like squares, for example. Do this. Squares are going to be a little bit different because, I mean, a square is a square. There's not a whole lot. You're going to really focus on the angles. In a square, they'll all be right angles. Now, the angles are what make a shape that particular shape. It's not the measurement of the sides, it's the angles. As long as if you had a square, like this smaller one, that measured 2 on every side, 4 right angles, all the same side measurement, that's a square. This one here, 4 right angles, they all measure 5, they would be similar because they're the same shape, but just a different size. Okay? Now, if you had something like this, and you had 4 right angles, would this be similar to that original square? Just by the eye test. Alex? It's the same shape? It's a rectangle. A rectangle is the same as squares. No. Each of these sides will also be proportionate. Okay? And we'll get to all that. We're going to focus on the sides. We're also going to focus on the angle measurements as well. Squares are going to be easy. Triangles maybe not as much. Okay. Now let's focus on the bottom of page 267. We've got a couple of different, well, not different triangles, separate triangles. I won't be able to draw them perfectly in the book, or like the book does, okay? So look at the bottom. We've got triangle A, B, C, triangle F, G, H. Bottom of 267. $53, $44, $44, $34, $50, $40, $51, $75, and $60. Okay. Now we're going to just use these two triangles and just to illustrate what it means for them to actually be similar. It's one thing to look at them and say they look like they're the same shape. There's another thing entirely to prove it. Okay. The first thing that we can look at, see, there's on a triangle, there are 6 different parts of it that have to be, if not equal, have to be proportionate. Angle A, let's use angle B is equal to what angle on the other triangle? Notice here, angle B measures at 53. That is the same as which one? F. This one, G? Correct. Angle C, 44 degrees, is the same as which one? Leanne? Angle H. Now, we need to, in your book, it'll tell you what the angle measurement is, but on the assignment, they might not. A triangle, its internal angles measure up to be 180. No matter what kind of triangle it is, the interior angles will add up to be 180. So if I've got 53 and 44, I've got 97 so far. Subtract that 97 from 180, and I get 83. Angle A corresponds with angle F, and there's the proof right there. Your angles will be equal. Okay? The angles will be equal. They have to be equal. Question?
Yes. Okay. So when you're doing that add
Yep. Angles, yeah. So if I know that all three of my angles are going to measure up to be 180, I'm going to add up the ones I have, 53 and 44, see how many degrees I have so far. That's why I added them together and got the 97. So if I already have 97, subtract that 97 from 180, and that gives me the 83. How can you check it? How can you check it? Add all three of them up. Add the 83, 53, and 44, and you should get 180. All right. Now, like I said before, it's the angles that make the shape. The angles make the shape. If you had a triangle, and don't write this down, but if you had a triangle that looked like this, is it the same as either one of these? Does it look remotely similar? Because this looks like it's how many degrees? 90? This here looks like it's about like 20. And then if that's 90 and that's 20, that would be about 70. Notice how the angle measurements make that triangle look a certain way. All right, so that's one thing that has to be equal. The other thing about triangles to determine whether or not they're similar is going to be their side measurements. So let's establish something. Let's say segment AB, remember segment, that's a part of a line. Segment AB on this triangle would correspond with what segment on the other one? Key. Any question on how we got that? BC goes with GH, and AC goes with FH. Now, suppose we should add the little squiggly, because they're not equal, they're similar. FH. Pardon me? Squiggly means similar to or about, corresponding, however you want to look at it. It doesn't necessarily mean equal, because they aren't equal. But they need to be proportionate. So let's take the measurement for AB, and let's put it over the measurement for FG. Okay? There's a certain ratio that is associated with these two. What would they have in common? 17? How many 17s are in 34? many 17s and 51? They're working off of a 2 to 3 ratio. So now we need to test the other sides. BC is 50. GH is 75. Are they running on the same 2 to 3 ratio if you simplify the 50 over 75? 25, right? How many 25s, how many quarters, and 50 cents is 2, and 75 would be 3. And then the other one we have to test is the one over here. 40 and 60. Are those sides also working on the 2 to 3 ratio? Because they have 20 in common. So if they're all working out with the same ratio, these triangles are definitely similar. If there's a ratio that does not work out, even if it's one of them, and you break it down, you simplify it, and it's not the same as the other two, that triangle is not similar. Africa. Okay, so the 6 parts, 3 of the angles, those have to be what? The angles have to be equal. If the angles aren't the same, the shapes aren't the same. The other part, they have to be proportionate. Now, sometimes they might not give you a side measurement, and you'd have to figure it out, and we'll get to that too. Not hard. Not hard. Okay, so it looks like a lot, and they kind of, out of the middle of nowhere, totally jump you right into the geometry stuff without any warning. So, but that's good. That's good that those of you that were here last year, we did all those definitions. Remember that? Maybe we could bring those back. And, yeah, we had those quizzes. And remember that? See? Let's together look at page 269, number 1. We are going to determine whether each pair of figures is similar, explain why or why not. What's the first thing you notice about those two triangles on number 1? Anything that you notice? Please share. Mia? There's decimals. Okay, good. Sophia? One of them's upside down. Does that matter when testing it for being similar or not? No, the shape is still the shape. Okay, so one of them is just inverted. All right. So if I try my best to duplicate these two triangles, X, Y, and Z, and this one, KTV. Okay, and then we'll fill in. Do you need for a second while I fill this in? Your book. Okay. What I want to do is I want you to tell me which angles on this first triangle, XYZ, which angles are they equal to on angle KTV? Take a second and get that down. Which of these is unmistakably, which of these are unmistakably equal? If it were me, I would first of all focus on the only one that's different, which is angle Z, which is 50. That would correspond with which one? Okay, so we'll go ahead and we'll get that down. Now, we have to understand that these have been inverted or flipped. Okay, so angle T or angle X corresponds with which one? T. and angle Y corresponds with angle V. Yes. Yeah, it does matter. It does matter. Because here, we'll go on and we'll say, all right, line segment XZ, line segment XY, and YZ. XZ, this one, would then correspond with what line segment on the other one? And you know, the nice thing is that you could use these angles. What did we say? XZ. XZ was T and the K. KT, same segment. Okay. XY would be TV, and YZ would be KV. Sure. All right, just give me 1 second. I'll give him one. I'll give him one to test. I want you to test the ratio and see if they are proportionate. If I know that XZ measures out at 3, and it corresponds with KT, and that measures out at 4, make sure that all the other ones follow that 3:4 ratio, even the decimal. Yep, simplify it. Hold on. Does anyone even watch these? Here's a major clue for you. They tell you that they're similar. This sign here means that they're similar. The order in which they tell you that it's similar matters. So when they say MNO and JKL, M goes with the J, the N goes with the K, the O goes with the L. So by them telling you that it's similar, they're already giving you a major clue. So number one, angle M corresponds with what angle? F. Okay, so number one, on your sheet, yes, you need the angle sign, angle J. Number two, angle L corresponds with, Mia, angle O. Number three, line segment ON corresponds with, yes, the order matters, Alex, LK. So let's make sure we put that line segment over it. Number four, angle K corresponds with angle N. K goes with N. JL MO. And 6 MN. Alex. Oh, really, though, JK. What is the ratio of the lengths of the corresponding sides? Do it. 7. What is the ratio of corresponding lengths? All right, so take a look at number 3. ON corresponds with which one? What did you have for? All right, so ON measured out at what? 20, and then the corresponding side was what? LK was 15. That's the ratio they're working with. Simplify it. So they're working at a 4:3 ratio. Test the other sides. See if they're working at a 4:3 ratio. So if we have MN, which measured out at 32, I'm going to put that 32 over what corresponding side in the other triangle? Keep 24. And then the last one, 24 for MO and 18. Test them out to make sure that they 8. So we should have 4:3. And for this one, we divided them by 6, and we had the 4:3. So yes. No, the ratio is what? That's what they wanted to do, the ratio. So we had to make sure we tested all of them. You don't sit there. Numbers 8 through 13, you're gonna do as homework. Numbers 8 through 13, the directions say what? They're similar. They're already telling us that they're similar. So number 8, those are pentagrams. Okay. They don't have letters to show what sides we're talking about, but it's pretty easy. So we're going to take a 5 from the first pentagram and compare it to what's the only measurement I have in the other one? 4. Okay. Now I need to find out the value for x. So you see where x is, right? Does it have a corresponding side on the first pentagram? And what's the measurement on that corresponding side? 5. So we're going to compare it to 5 over x. A ratio, a proportion, just like we spent a lot of time figuring up until today. Now, you should know right away that x is going to equal what? Look at the first pentagram. They all equal 5. All of the sides are the same. On the second pentagram, if one side equals 4, they'll all equal 4. But if you don't see that, then we're going to run it through our test. Is there a relationship from 5 to 5? Times 1. 4 times 1? There we go. Yeah. It's going to be okay. Number 9, and then I'm done. Okay. First one you want to set up is where you have an existing ratio. So looks like it's the 24, the long side, on the first triangle, matches up with what's the long side of the second one? 18. Okay. Then I'm looking for y on the same triangle that had the 18. So that's going to be where the y goes. And that corresponds with the 16. Do it. Good. So help me out. What did you do? How did you get it? Divide them both by what? By 3? 8 and 6? Yes? Now I can test for relationship. 2y equals 12. Is there only one way to solve these? More than that. All right, so 10 through 13.